Welcome to my channel Divyas Maths.
Today we will see exercise problems on the chapter sets. So the first one is, which of the following are sets? Justify your answer. The collection of all the months of a year beginning with a letter J. So we can count the months, right? So they are June and July. Correct. So it is a set. Yes, we can count the months with the letter J. So the next one is the collection of 10 most talented writers of India. In my view, there are 10 talented writers. And in the same way, so everyone has a talented writers in their opinion. So this is not a set. We cannot decide only these 10 are a talented writers. The collection of all boys in your class. We can count the number of boys in our class, right? So this is a set. So the next one is, if A is equals to 0, 2, 4, 6, B is equals to 3, 5, 7, C equals to P, Q, R, then fill the appropriate symbol. So if you see here, A contains these elements, B has 3, 5, 7 and C has P, Q, R elements in it, right? To see the set A, you have an element 0, right? 0 belongs to set A. In the same way, if you see 3 is in B, it is not in C, right? So 3 does not belongs to C. And where is P? P is in the set C. Yes, so it belongs to C. 8, if you see 8, the element 8, do you see in any of the sets? No, right? It does not belongs to B. Express the following statements using symbols. So here we have written using symbols, right? So in the same way, we need to express these statements using the symbols as well. So the element X does not belong to A. This is the symbol, okay? I belongs to set of natural numbers. So in the same way, 8 does not belong to prime number, set of prime numbers P. The fourth one is, state whether the following statements are true or false. Justify your answer. S is equals to 5, 6, 7 implies 8 belongs to S. So in the set containing elements, do you see 8? No, right? So this is false. 5 belongs to set of prime numbers. So the set of prime numbers is P is equals to 2, 3, 5, 7, 11, so on. 5 belongs to set of prime numbers. Yes, so it is true. S5 belongs to W, where W is a set of whole numbers. So what are whole numbers? They are 0, 1, 2, 3, so on, right? So do we have minus 5? No, and minus 5 is an integer. This statement is false. So the next one is, write the following sets in the roster form. Okay, B is equals to X such that X is a natural number smaller than 6. So how do we write it? B is equals to, what are the natural numbers? 1, 2, 3, 4, 5. It should be less than 6. Correct? So we'll take till only 5. And the next one is, C is equals to X such that X is a 2-digit natural number such that the sum of its digit is 8. What are the 2 digits? If you add, the answer is 8. They are 1, 7. Correct? If you add, it is 8. In the same way, 2, 6, 3, 5. Yes? 4 and 4. Correct? 5 and 3, 6 and 2, 7 and 1. Yes, so C is equals to 17, 26, 35, 44, 53, 62, 71. Clear? D is equals to X such that X is an alphabet in the word better. Okay, so we have seen that the roster form, the elements will not repeat. Yes, so it will be B-E-T-R. Yes, so the E is repeating and T is also repeating. So we are not taking it second time. Okay, B-E-T-R is your roster form for the better. So E is equals to X such that X equals to 2n square plus 1. N is less than or equals to 3, greater than or equals to minus 3. This is the condition they have given. So N belongs to integers, right? So because we have a negative numbers as well. So N can be minus 3, minus 2, minus 1, 0, 1, 2, 3, right? So let's take first with 0, that is N equals to 0. So what will be the X value? That is 2 of 0 plus 1, that is 1, correct? So for N is equals to 1, X is equals to 2 of 1 plus 1, that is 3. Yes, here 1 and this is 3. In the same way, for N is equals to 2, we get 2 of 2 square is 4 plus 1, that is 4 2s are 8 plus 1 is 9. Okay. So for N is equals to 3, we get 2 of 3 square is 9 plus 1. Okay, that is 9 2s are 18, 18 plus 1 is 19. Clear? If you observe minus 1, minus 2, minus 3, for N is equals to 1 and for minus 1 as well, here if you take minus 1 whole square, that is 1 only, 2 or minus 2. Even for minus 2, you get a positive, right? So 3 or minus 3, you get a positive integer only. E is equals to, so what is the roster form we got? 1, 3, 9 and 19. Now write the following sets in the set builder form. See this, these are the multiples of 3. Yes, so A is equals to X such that X is a multiple of 3. So it is ending by 12, right? We are not taking 15 because we have a condition and X is less than 15 or X is less than 13 also, it is fine. Next one, 5, 25, 125 and 625. So this is like 5, 25 can be written as 5 square. 125 is 5 cube and 625 is 5 power 4. That is B is equals to X such that 5 is common, right? The bases are same, only the powers are changing. 5 power P, I am taking 1, 2, 3, 4 as P. P belongs to a natural numbers and what is the condition? That is P is less than 5. Yes, we do not have 5 power 5. It is only ending till 5 power 4. So P is less than 5. Okay. So the next one is 1, right? 4 can be written as 2 square. Correct. So 9 can be written as 3 square. In the same way, 4 square, 5 square, so on till 10 square. If we write it in the set builder form, that is x such that c is equals to x such that, see, 1, 2, 3, 4, 5. The bases are changing and the powers are same only. Correct? So, I am taking the bases as p square. The powers are same. So, I am taking it as p square, where p belongs to natural numbers and p is less than 11. P is 10. Right? We are stopping till 10. Okay, that is the reason we have taken p is less than 11. So we'll see the next exercise. The first one is, if a is equals to 1, 2, 3, 4, b is equals to 1, 2, 3, 5, 6, then we need to find a intersection b and b intersection a. So first let's see a intersection b. So what is a? 1, 2, 3, 4 intersection. What is b? 1, 2, 3, 5, 6. Right? So if you want to find a intersection b, you need to see the common elements in both the sets. Right? So what are the common elements? A, 2, 3 are common. So 1, 2, 3. This is a intersection b. Then we need to see b intersection a. What is the set b? 1, 2, 3, 5, 6. Set A is 1, 2, 3, 4. Right? So what is B intersection A? It is 1, 2, 3 and 1, 2, 3. 1, 2, 3 are common in both the sets. Yes? So 1, 2, 3. In question, they have asked, are they equal? If you see A intersection B and B intersection A, the sets have the same elements. So, A intersection B is equals to B intersection A. So, the next one is, if A is equals to 0, 2, 4, find A of null set and A intersection A. What did you notice from the result? So, this is your set A, right? So, we need to find A intersection 5. Yes? So, what is the set A? That is 0, 2, 4. Correct? Intersection. This is your null set. Correct? So, do we have any common elements in both? No, we don't have any common elements, right? So, this is your null set itself. Okay? And in A intersection A, what is A? 0, 2, 4 and intersection 0, 2, 4. Yes, all the elements are common. Correct? That is 0, 2, 4 only, which is A. Correct? So, what did you notice from the result? See, A intersection A is A and A intersection 5 is your null set. So, they have given A and B sets. Okay, so we need to find A minus B and B minus A. So, what is A minus B? What is set A? That is 2, 4, 6, 8, 10. What is B? That is 3, 6, 9, 12 and 15. If you want to find A minus B, you need to take all the elements of a set A and you need to see if there are any common elements in both the sets. If there are common elements, cancel them and take remaining elements of a set A. That is 2, 4, 8 and 10. In the same manner, B minus A. B is 3, 6, 9, 12 and 15 minus A is 2, 4, 6, 8 and 10. So what are the common elements? There are 6, right? 6 is common. So we'll cancel 6 and we'll take all the elements which are in B. That is 3, 9, 12, 15. This is A minus B. This is B minus A. A and B are two sets. Okay. If A and B are two sets such that A is subset of B, then we need to find A union B by taking an example. When do we say it is a subset? When all the elements in A is also an element in B. Okay, so if we are taking an example, A and B are two sets. All the elements in A is also an element in B, right? Then we can say A is a subset of B. Then what is A union B? 1, 2, 3. Union, what is B? 1, 2, 3, 4. Union of both the sets, right? That is 1, 2, 3, 4. We need to take the elements of both the sets and we should not repeat the elements. 1, 2, 3, 4 is your B only, right? So this is the problem for the fourth one. Let A is equals to AX such that X is a natural number. Okay, so A is equals to, they have given a set builder form for all the sets. Okay, we need to find the roster form. So A is equals to, what is A? A is a set of natural numbers, right? So 1, 2, 3, 4, 5 and so on. And B is X such that X is an even natural number. So 2, 4, 6, 8, 10, so on. C is odd natural number, that is 1, 3, 5, 7, so on. Okay. And D is prime number. 2, 3, 5, 7, so on. Okay. So we need to find A intersection B. Okay. So what is A? 1, 2, 3, 4, 5, 6, so on. Intersection. What is B? 2, 4, 6, 8, 10, so on. So what do you get? What are common in both the sets? 2, 4, 6, so on are common. In the same way, A intersection C. A is 1, 2, 3, 4, 5, so on. Intersection. C is 1, 3, 5, 7, so on. So intersection is common elements in both the sets. 1, 3, 5, so on. So in the same manner, please find A intersection D, B intersection C, B intersection D and C intersection D. The next one is A is equals to 3, 6, 9, 12, 15, 18, 21. B is equals to C and D. They have given the values of A, B, C and D. So we need to find A minus B. Yes, A minus B. What is set A? 3, 6, 9, 12, 15, 18, 21. Minus what is B? 4, 8, 12, 16 and 20. So what is A minus B? We need to take all the elements in A and cancel the elements which are common. Okay, only 12 is common. That is 3, 6, 9, 15, 18, 21. Okay, the second one is A minus C. 3, 6, these are the sets set in A. 21. And what is C? C is 2, 4, 6, 8, 10, 12, 14 and 16. We need to cancel all the elements which are in common. 6 is common. Yes, 12 is also common. So what are the remaining elements in A will be your answer. 3, 9, 15, 18, 21. 21. So in the same way, third one is A minus B. A is 3, 6, 9, 12, 15, 18, 21. Minus what is D? 5, 10, 15, 20. Yes. So what are the elements which are common? That is 15. Okay. So we need to write remaining elements of A. 3, 6, 9, 12, 18, 21. Fourth one is B minus A. What is B? 4, 8, 12, 16, 20. Minus A is 3, 6, 9, 12, 15, 18 and 21. Yes. So what are the elements you have in common? That is 12. Right? Only 12 is common. So you need to take the elements in B only. Okay? Because it is B minus A, you need to write the elements in B. So in the same way, please do C minus A, D minus A, B minus C, B minus D, C minus D and D minus.
Next video, we will solve few multiple choice questions.